Hi guys, welcome back to another video, and today we are talking about software. Specifically, we're looking at the difference between application and operating software, and we're going to talk about what a computer actually does, what the hardware actually does. So let me take you on a tour of my operating system. This is the Mac OS X, and if I open up a Finder window, I can click on Applications. And this is my application software. So anytime I want to achieve an objective, if I've got a job that needs doing on the computer, I turn to my application software. So application software is the stuff, the applications that the user wants to do. So I've got Firefox open in the background here. That's an application. I've got some Office software. LibreOffice will contain a word processor and a spreadsheet. I've got MATLAB here for processing data. Now TV, this is there for entertainment. I've got some other stuff. Now the operating system sits between this application software and the hardware inside the computer. Now the bit that actually deals with the hardware is called the system kernel. Now you don't need to know that except that it's mentioned in a later video. So I'll name drop it now just so that you recognize it when we get to that. But the operating system also contains a bunch of tools that are useful to help the user out in a number of situations. And I can see some of those if I go down here and click on Utilities. There are others, I would argue there are others in the applications as well, but these would typically be some of the things that you would expect to come packaged up inside an operating system, but you wouldn't call them applications. So if there's a problem with my with a disk, with a flash disk, or with the hard disk inside the computer, I might turn to the disk utility. So nobody bought a computer to use the disk utility, but if you've got a problem, you're going to be glad that it's there. Same with a screenshot. It's useful to have, but it's not really an application. Although having said that, if you're publishing stuff, maybe a screenshot software is essential for you. And there is therefore a blurred line between operating system tools and applications. For example, iMovie comes packaged up as part of this operating system. You get it with this operating system, and that's for editing videos and things like that. But I don't think anybody would argue realistically that iMovie is an operating system tool. Most people would say iMovie is an application. It's not terribly important anyway. Now, when the application runs, the operating system has to convert what the user wants to achieve in the application into things that the hardware inside this computer can actually do. Now, the things that the hardware can actually do are called the computer's, or rather the chips, the processor's instruction set. Now, the instruction set is what the computer is physically able to do, and everything that you want, everything that it appears to be doing, is actually made up of millions, many millions of these instructions. And I can show you the instruction set, or at least some of the instructions, most of the instructions, in an Intel chip computer. So these things are the instructions that your computer, if you're running Intel, can actually do, can physically do. So every time you run a piece of software, that piece of software has to be converted into these. So let's have a look at one of these. DEC. So if a computer executes the DEC command, the DEC instruction, it subtracts 1 from a memory register. So no user ever went on to an application and asked it to run the DEC instruction. It's the operating system that helps go from the application into these instructions. And if you look there, I think there's about 300 of these. There they are in alphabetical order. Now, one interesting question that we might ask is, okay, there's 300 of these here. How many do we actually need? And the answer is not very many. Now, if I go over to here, this might look like Wikipedia, but I promise you it's not. This is a description of what's known as an esoteric programming language. And this particular esoteric programming language has only got 8 commands. And the point that it's trying to make is that you could have a processor on a computer that executes just these instructions, these 8 instructions, and you would be able to compute everything that all of these could compute. So anything that you can compute with these, you could compute with just these 8. And if we scroll down, this is an example program written in this esoteric language. And the blue here has been added in English just for us. So the computer will ignore that. It's the pink, the red and the green bits here, the instructions, that actually get executed. And this particular esoteric programming language is called Brainfuck, and you can see why. This is a program written in this esoteric language, and this particular program will, when I run it, output the lyrics to 99 bottles of beer on the wall, I think. Let's run it and see. Oh, I need to refresh it maybe. Okay, here we go. Let's try that again. Let's run the program. And there it is, 99 bottles of beer on the wall, 99 bottles of beer. Take one of them down and pass it around and you'll have 98 bottles of beer. And it will just go through all of them down to 0, or maybe just down to 1. Let's wait and see what happens. And what can we learn from this language? Well, there's 2 take-home messages. First of all, I want you to appreciate that in order to compute, you don't need to be able to do a lot of stuff. In fact, you can reduce it down beyond 8. You don't even need 8 instructions in order to compute everything that could possibly be computed. And the other thing, maybe more importantly, is that this thing here, this set of squiggles, is what's known as source code. So this is a software's source, and this is the program that an operating system will turn into those instructions. So you write a program like that, you give it to the operating system, and the operating system turns it into instructions. Now, most source does not look like that. Before we go and see what it does look like, let's just go up, and it stopped at 1. So we had 1 bottle of beer, we get down to 0, and then it stops. Source code usually looks like this. So this is some source code that I used in a research project, and I wrote it in a program called R. And then my operating system, there's a tool. It wasn't built into my operating system. I had to install something, and you could argue, I suppose, that that was an application that I installed because it didn't come prepackaged in the operating system. But like I say, there's a blurry line between all of this, so I wouldn't worry about that. I installed some software. That software uses some other software that's built into the operating system, and it means that I can write programs like this and and run them on a computer that actually only does those 300 things that I showed you a few moments ago. Now, one take-home message from this is that if you want to change the software, what you really need in order to stay sane, you could do it just from looking at the instructions that are executed, but in order for most users to be able to change the software that I have written here, you would need the source code. So if I give this to somebody, this file, they can change X from 5 to 6. Or whatever it happens to be. Now, in theory, you could do that just by looking at the instruction set. The instructions that the operating system comes up with. But that would be extremely technical, extremely difficult to do. Realistically, what you need in order to edit my software is the source code. Now, I'm making a big deal of that because it's going to come up in the next video. But we will leave this video here for now, and I will see you on the next one.